All right, we are going to start lesson 7.6, the fundamental theorem of algebra, which we've already kind of touched on previously, dealing with the idea that the degree of a polynomial tells you the number of solutions, the number of zeros, and that includes real and imaginary. And that's going to come into play a lot today. We're going to look at the degree, we're going to figure out how many answers we should have, but this time we're going to find them as well. And to help us with this, we're going to just ask a couple of questions. And the first question we're going to ask ourselves is, why do we even need to know if a binomial is a factor of a polynomial? And what we're going to do is, if we look at this right here, I give you the number 1,452. And if I were to ask you just plainly with numbers, you know what, does 12 go into it? Or does 16 go into 1,452? You should be able to figure that out just by doing numbers. Which one of those goes in there perfectly? And when I ask you with numbers, it's a very simple process. You would just type it in your calculator, as I'm showing here, and you have to choose which one of those goes into 1,452. And you should know right away, well, it's got to be 12. And because the difference is right here. We can see right now that 90.75 times 16 is 1,452. That means, if I were to do division, I would get a remainder. But if I do division here, I get a remainder of 0. And you know that with numbers. You know if you take 10 and divide by 2, it's 5, that there is no remainder. And it is no different for binomials. And so that's what we're going to use to help us out, is we're going to break an x cubed polynomial into an x squared, which I touched on in the previous overview video. So if we take a look, here are two synthetic divisions in order to save time worked out for you. And these synthetic divisions are asking which of these binomials, x minus 3 or x plus 5, is a factor of x cubed plus 6x squared minus x minus 30. And if you're asking which is a factor, well, it's the same rules as it was with numbers. If I were to pick whether it's x minus 3 or whether it's x plus 5, I'm going to choose this one. I'm going to say x plus 5 is a factor of that polynomial. And the reason why is right here. You have a remainder of 0. That means that x plus 5 went in there perfectly. If I look over at the x minus 3, it has a remainder of 48. That means it doesn't go in there perfectly. There's leftover stuff. And so our goal in this lesson is to always try and get a remainder of 0. That is the goal. That tells us if it is a factor. And that's what the factor theorem lets us know. The factor theorem states that if you get a remainder of 0 when performing division, the expression you divide it by is a factor. So a remainder of 0 is a good thing, just like it was for numbers. It tells you you have a factor. And so that's our goal whenever we're doing division, is we want that. So here is the overview of this lesson. I am going to give you a polynomial. And again, it could be an x cubed, it could be an x to the 4th, it could be an x to the 5th, whatever. Now, I'm not going to be mean and give you too many 5th power ones, 6th power ones, 7th power ones. We're primarily going to focus, I would say, primarily on x cubes. I'm going to give you some polynomial just like above that was an x cubed. And I'm going to ask you to solve it for every single answer, which the fundamental theorem of algebra tells us we are going to have to solve for 3 answers if it's x cubed. The problem is we can't do much in the x cubed form. We are going to then either have to be given a factor, or you can be given a 0, and you're going to do synthetic division with it. Because if I give you one of those, we learned just based off the previous stuff, you should get a remainder of 0. But if I divide an x cubed by a factor, which is going to be an x, I'm going to get, after the division, a quadratic. And a quadratic, we know how to solve. A quadratic is back to chapter 6. It's either going to be factorable, which means we're going to factor it, doing either sum of cubes, difference of cubes, sum of squares, difference of squares, AC method, GCF, any of those. Or it's not factorable. And when it's not factorable, that's when we go back to the good old quadratic formula. And so you're going to see the process is very, very, very similar on all of these. So that is the first page of the notes, meant to just explain what our purpose is and what we're going for, which is we're going for a remainder of 0. We're going to do synthetic division. We're going to end with a quadratic, and then we'll see where we go from there.